Hello everyone, this is Mohammad Atif, and we are in a series to present you the solutions, daily solutions of Geeks for Geeks as well as Leetcode. So today's Leetcode daily problem is jump game 4. So in this problem what we are given is we have been given an array integer elements and we are initially positioned at the 0th index, and what our aim is to reach from the 0th index to the last index of this array. So there are two possibilities. The first possibility is that if you reach from the 0th index to the last index, then you need to return in how many minimum steps can you reach from the 0th index to the last index. The other scenario is that suppose you start from the 0th index but you are not able to reach at the last element of the array. So in that scenario what you need to return, you just need to return -1 or something. We will see what we need to return. We need to return -1, although it is not mentioned in the question. The test cases have been set in such a manner that you will always be able to reach in the last position. So let's see how the solution will appear. So if you are standing at, okay, let me open my note. Let's read it a bit. So yes, suppose you are standing at ith index. From ith index you can go to three positions, right? You can go to either I plus 1, either I minus 1, or at some index j in such a manner that array of I is equals to array of j. Cool. So if you are standing at this index, so you have three options to move, and similarly from this you will have three options to move. So if in a broader terms, if we want to visualize it, it will seem like a graph problem. Like if you are initially you are initially at one node, and again from that one node you want to move to other three nodes, and from that three nodes you want to move to other nine nodes. So it is sort of like graph problem. I mean, so let's look how we will deal with this problem. Suppose, let me erase it all. Suppose I am at index 2. Sorry for this. Suppose I am at index 2. So if I am having the elements like 4, 3, 2, 4, 2, 2. So you can see that 0, 1, 2, 3, 4, this is the indexing that is done. So if I am at this position, I will either move to index 1, I will either move to the next index, or I will move to such an index such that the element value is equal. That means from 2 I can move to 4 and 5. So I can move to 4 as well as I can move to 5. Why so? Because the value at 4 is 2 and the value of 5 is 2, and we have been given in the question that in case my array of I is equals to array of j, so we can move to that index j. So let's see how. Now from this index I again can move to the 0th position, I again can move to this 2th position. Now from index 3 I can move to this 2 position, I can move to this 4 position. Fair enough. I'm sorry, from this third index we can also move to 0th index. We can also move to 0th index because this 0 is also containing 4. So what you can see from here, you can see from here that this subtree is repeating. I mean, a subtree will form from here that will be again repeating. This is again repeating. So we need to take care of this repetition also. So what we need to do is we just need to find the first level. This is level 1, this is level 0, this is level 2. So our aim is to find the first level where the where we will be able to reach the last index of the array. So let's see how we will do it. Suppose so in case, suppose this is an nth level. Suppose this is an nth level and some subtrees have been formed above it, and here you are able to reach this n minus 1 index. So as soon as you reach this n minus 1 index, you will return your answer from here. Why so? Because the more deep you go, you will be able to reach the n minus 1 index, but it will take more time, and we always, and in this question it is mentioned that we need to take minimum amount of time. So okay, so let's see the test case example. This is the test case that has been given to us. So initially we are at 0th index. Cool. Let's visualize it a bit. Initially we are at 0th index. We can move to first index. Also we can move to fourth index. Why fourth index? Because it has the exact value as same as 0th index. Now from first index we can move to 0th index. From first index we can move to second index. Fair enough. From fourth we can move to third index. From 4 we can move to fifth index. From 4 we can move to 0th index. But since since this 0 has already been visited, so we will maintain a visited array. So we will not visit this 0 again, and similarly again we will not visit the 0 again. So let me erase this for better clarification, and this 2. Cool. Now, from 3, now from 3 where we all can move, from 3 I can move to 2, but 2 is already visited, so we will not move to 2. From 3 I can move to 4, but 4 is again visited, so we will not move to 4. Our next step will be to move to ninth index. Since since the value at index 3 and index 9 are equals, we can move at this position. Since this element is first visited at third level, this is level 0, level 1, level 2 and level 3. So it means you have visited the last index in the third level. So your answer will be 3 levels. So since we are talking about level, so what algorithm comes to your mind? Which approach comes to your mind? Think of it. Pause the video and think. The approach that comes to your mind is breadth first search. We will search in a breadth first search manner because we are traversing at each level. So we'll look at it in a breadth first search level. So at this index, if you are at this index, you can easily move to this index, you can easily move to this index. So you will have two options, either I minus 1 or I plus 1. But how do we check the index that has whose value is equal to the current index? So for that we will make a map of integer or factor of int. I'll show you in the code. It will be better to understand in the code. So let's move to the coding part. So I mean, to summarize this solution, this is basically a breadth first search problem with three options from each node. So let's begin with the coding section. This is where we have the standard queue. We have pushed the 0th index. I mean, we are starting from 0th index, so we have pushed the 0th index in the queue. And initially my level is 0 since I am at the 0th level, so my level is equals to 0. So I have made a map of factor of int. So what this is doing is, it is taking suppose I have 4 at 0th index also, 3rd index also, 4th index also. So this map is storing that 4 is present at 0th index, 3rd index, 4th index. This map is storing a vector of all those indices at which the value is actually present. So this is the function of map over here. Okay, now we will iterate in this queue. This is normal BFS function. If you don't understand BFS function, I would recommend you to please read this BFS algorithm beforehand and then come to the solution. You will be better acquainted to the solution then. So let's grasp how it is being done. So the size is equals to q dot size. Initially this size is containing just one element. This queue is just containing one element, so this size will be 1. That means you will just have one node, and from that one node you will have three options. So my current index is q dot front. I mean at this index I am standing at q dot front, and then I will pop that element from the queue. And in case the element that I have popped from the queue is equals to n minus 1, what does it actually mean? It means that I have actually reached the last pointer of the array. So just I need to return the level. So what is this level? This level has been updated each and every time after each level. Cool. So if I am able to reach, so I will return level. And in case my index minus 1 is positive, I mean I am standing at this index, current index. If my index minus 1 is a valid index, and if it is not visited, what I do, I first mark it visited. Like I mentioned one time in the algorithm that we are again and again running into loops, like see, this 2 is again visited, this 2 is again visited. So to avoid these situations, we are maintaining a visited array, right? So just I maintain this visited array, I marked it as visited, and I push the index minus 1 into the queue. Similarly I did with the index plus 1. If it is valid index, I have checked it here, and if it is not visited, I have marked it visited, and I have pushed that next index into the queue. Now my next goal is to find out the index j which need to be pushed in the queue. So let's see how. Okay, cool. So suppose my current index is suppose my current value is array of index. Like if I am standing at the index element, my value is array of index. Cool. So now I need to check how many elements actually are present apart from this index, so which have value actually equals to value. So I am iterating in this map of value. So this it will be containing all the vector elements whose indexes it will be actually containing the indexes whose value will be equals to value array of index. Cool. So now let's look at further. In case my id is not equals to index, I mean if 4 is present at 0th index also and 3rd index also, and currently I am standing at 0th index, I will not consider my 0th index. I will need to consider the next index. So this is the stuff that we are doing here. If id is not equals to index, and by visited of the next id is equals to 0, it means that that index has not been visited. So what I will do is I will simply push that element into the queue and I will mark it as visited. And after all this is done, I will just simply erase that value from map, and then I will increase the level. In case this whole while loop gets over and my queue size also becomes my queue gets empty, and what does that mean? That means that I was not able to reach the last index of the array. So what does it simply mean? It will simply return -1, although it has not been mentioned in the problem, but for the sake of our satisfaction, we have mentioned we just return -1. Why so? Because we have not found any element. In case we had found any of the levels at which we were able to reach the n-1 index, we would have written it over here, return level. Cool. So in case if you have any doubt regarding this problem, feel free to ask me in the comment section. We will be available for you. So thank you, and do subscribe my channel. We are we will be daily uploading the problems of Leetcode and Geeks for Geeks. So do support us in our this mission. Thank you.